Here's problem 19. So problem 19 is just asking you to find different areas under the normal distribution curve. So part A says find the area under the normal distribution curve to the left of z equals 1.81. Okay, so let's sketch this out. Oops, that wasn't a very smooth curve, but that's okay. Here we'll put z equals 0 in the middle. And we need to figure out where 1.81 is. It's going to be maybe somewhere around here. But the truth is, it doesn't matter if you the exact position doesn't really matter. All that you need to realize is that since z is positive, 1.81 is going to fall to the right of z equals 0. Okay, so I'll make my, okay. So here's z equals 0, here's z equals 1.81. And we want to find the area under the standard normal distribution curve to the left of z equals 1.81. So let me shade everything that we need to know. Okay, oops, why is my shading not working? There we go. Okay, everything to the left, not just from 1.81 to z equals 0, but everything to the left. So what I know right now is what I'm actually going to do. I shaded everything in red, but let me actually split it into two different colors. I'm going to do blue over here, and I'm going to do green over here. And the reason for that is because when I look things up on my chart, it's only going to give me the area from z equals 0 to z equals 1.81. It's not going to give me everything to the left. So, but what I can do is I can say, look, this blue area that I shaded, this is everything to the left of z equals 0. That's half of my distribution. So my blue area is 0.5, and the green area is what I'm going to look up. Okay, so let's go over to our z table. Okay, now 1.81 is on the back. Okay, so if you just kind of go, when you look at all the z's on the front, you realize you don't have 1.81. You keep going, you get to the back, and you say, okay, 1.81, 0.465. And here's the front of the table, which I just wanted to bring in just to show you this, to recall that everything on the table is giving you the area between 0 and a given z value. So the value that we just looked up for 1.81, that's giving us that shaded area between 0 and z. So what we found from this table is that this area, the green area, is 0.465. So therefore, right, in part A, find the area under the standard normal distribution curve to the left of z equals 1.81. Our red area, right, the red area is going to be 0.5 plus the green, 0.465. So altogether, that's going to be 0.965. Okay, part B, find the area under the standard normal distribution curve to the left of z equals negative 1.75. So let's draw out our curve again. Let's make it black. Okay, here's our z equals 0. Just put it in 0. Negative 1.75 is going to fall over to the left, right? A negative z-score is going to be to the left of 0. Okay, so let's put in our z over there, negative 1.75. Okay, and let's shade what we want. We want to know the area to the left of it, so just this little area over here. Okay, so it's going to be a fairly small number, right? Remember, the total area is 1, no area is 0, so it's going to be much closer to 0 than 1, just based on looking at this picture. Okay, so let's go, and so if you remember, our z table doesn't have any negative values on it. So even though I have negative 1.75, right, what I have to look up at the table is positive 1.75. And we're going to use the fact that the normal distribution is symmetric to say that basically kind of this area here is going to be the same as, you know, this area here, or if you prefer to think of it as kind of this area is the same as this area, whatever it is. But we have this symmetry going on. So looking up positive 1.75, again, that's on the back. So that's 0.460. And that 0.460 is going to give us the area between our given z and z equals 0. So the 0.460, maybe I shouldn't use black, but I'll use black, 0.460. So the black part is 0.460, but what I'm interested in is the blue part. So what I want to do is I want to figure out how do I figure out this blue part? Well, this whole half is 0.5. So since the blue plus the black is 0.5, what I can do is I can just subtract. So 0.500 minus 0.460 will be 0.040. And that gives us the area of the blue. Okay. And I'm not just drawing this picture in order to demonstrate what you need to do. You should be drawing a picture yourself when you are given these problems, because it can really help you figure out if you're supposed to be adding, if you're supposed to be subtracting, should I be using this 0.5, should I not be using this 0.5, right? Every time you get one of these, you should draw a picture, you should label where z equals 0 is, label your given z, and actually shade in what you're looking for, because it can really help you just kind of figure out the mechanics of what you need to do. Okay, part C. Find the area under the standard normal distribution curve to the right of z equals 1.2. Okay, so again, here is 0, here is 1.2. We're now going to the right, so we're looking for this area. Okay, so again, it's going to be a smaller area. Okay, so we'll go ahead, we'll look up 1.2 on our table. Okay, so I go down, I find my z, it's going to be in this column. So here's 1.2. And the area is 0.385. And again, this is this area right here between 0 and z. So 0.385. So let's fill in our 0.385. Remember, everything you look up on that table is going to be between 0 and your given z. So the 0.385 is going to be right here. Okay, so now looking at our picture, right, we're going to have to use the fact that this half is 0.5. Okay, do I want to add, do I want to subtract, right? How do I figure out? I'm looking for that green shaded area. Well, if I know that kind of this, like the red plus the green equals 0.5. So to find green, what I want is I want to do 0.5 minus 0.385. And that comes out to be 0.115. So that's going to be the area of the green, right? The green part, which is 0.115, plus the red part comes to be 0.5. The red part we found on our chart, so we just have to add those. If you add those together, you check, it comes out to be half of the total area. Okay, now part D. Now we're looking under the standard normal to the right of z equals negative 0.9. So here is our 0. Negative 0.9 is going to be over here, right? And again, it doesn't really matter exactly where you draw it in. Okay, it doesn't need to be perfect. I probably drew it too far over, right? Probably a little bit closer to 0, but that's fine. As long as you put it on the right direction. So negative numbers should be to the left of 0, positive numbers should be to the right of 0. So now we're finding the area to the right of z equals negative 0.9. So shading in this area, but we want to go all the way to the right, not just a little bit to the right. We want everything to the right. So we're going to find a green area plus a red area. Now we know that the red is 0.5 because it takes up half of the area under the normal curve. So now we just need to find the green, and just like before, instead of looking up negative 0.9, we're just going to look up positive 0.9. So z equals positive 0.9 is going to be right here. The area is 0.316. So then adding that in, so this is 0.316. So the total shaded area, right, we're looking for everything to the right. So we're looking for kind of all of this. So to find all of that, right, we want 0.316 plus 0.5. So our total is going to be 0.316 plus 0.5. So adding those together, we get 0.816 is the total black shaded area, the green and the red together. Now, before we go into the next group, notice that for all of these first four, right, we just had one boundary, either everything to the left or everything to the right. There wasn't anything between. Whenever you have going all the way off to the left and all the way off to the right, you're going to have to use this fact about the 0.5 somewhere, right? So either you're going to be adding a 0.5 or subtracting from 0.5 or something, because the 0.5 is kind of half of the curve, and that's what kind of includes everything kind of just going all the way off to infinity. So you're going to have to use the fact that half of the area is 0.5 whenever you don't have two boundaries. Okay, so now we're going to look at the area under the standard normal curve between z equals negative 0.7 and z equals positive 1.4. Okay, so here's 0. Here's negative, I think I said 0.7, but 0.27. Negative 0.27 is going to be over there. Positive 1.4 is going to be over here. Okay, so to find the area between them, right, if I shade the whole thing in yellow, but if I think about what I can actually look up on my chart, right, I'm looking up the area between 0 and something. So if I look up this area, right, I look up the red area, and here I'm going to look up the blue area. To get the total yellow, I have to add them. Okay, so let's look those up. And of course, remember, when I'm looking up negative 0.27, I have to look up positive 0.27. Okay, so positive 0.27 is right here, 0.106. And what was the other one? 1.04. Let's find that. 1.04. Why can't I find it? Here's my z. 1.04. There we go. Okay, so the area between 0 and 0.27 is 0.106. I may have misspoken on that too. 0.106. And to 1.04 is 0.351. So now filling in those areas, this red area here is 0.106. And the blue area was 0.351. And I'm looking for everything between negative 0.7 and 1.04, so I'm going to add those two together. So when I add them, what I'm going to get is 0.457. Okay, and the reason I add them is because I need the area from both of those sections. Okay, find the area, on F, find the area under the standard normal distribution between z equals negative 1.25 and z equals negative 0.35. So let's put in our 0. Negative 1.25 is going to be farther to the left than negative 0.35. So it's going to look like this. Negative 1.25, and then here is going to be negative 0.35. Okay, so we're looking for this yellow area here. Okay, so what's important to realize that, right, negative 1.25 is farther from 0. Okay, so how are we going to figure out this yellow area based on what we can get from our table, right? Because our table is only going to give us distances between a certain area between a certain z value and a z value of 0. So if I look up 1.25, right, I'd get this blue area. And if I look up 0.35, I would get the green area. Right? So you can kind of see looking at this picture is that since what I want is the yellow, so I'll say like want yellow. What you can hopefully see from this picture is that the way that you get the yellow is by taking the blue minus the green. Right? The blue is this whole region, right? If you take off the green, what you're left with is the yellow. Since that's what we're interested in, right, that's what we want to do. So again, the blue is what we get if we look up 1.25, and the green is what we get when we look up 0.35. Okay, so looking these up on our table, 1.25 is here, 0.394, and the 0.35 is over here, 1.37. So let's add those in. So the whole blue is 0.394. And the green is 0.137. Okay, so to find that yellow, you want to subtract. So you're going to do 0.394 minus 0.137, which I may have misspoken at some point because I kind of am hearing 1.37 in my head. But anyway, 0.394, right, the blue part minus the green part minus 0.137. And what we're going to come out with is the yellow part, which comes out to be 0.257. Okay, so finally the last part, find the area under the standard normal distribution curve between z equals 0.15 and z equals 1.15. So here's z equals 0. Here on the positive side is 0.15, and here we got 1.15. So again, we'll use the same colors. We're looking for yellow, If I look up 1.15, I'm going to get this whole blue area. But if I look up 0.15, I'm going to get just this green area. So once again, if I just want the yellow, what I'm going to have to do is blue minus green. Okay? And notice I'm not trying to memorize like, oh, this is the bigger one, or this is farther away from 0, so I need to do this one minus that one, right? I'm not memorizing anything like that, or when I add this, or this time I add and this time I subtract. What I'm doing every time is actually drawing out the picture, seeing what it looks like, and using kind of the spatial of how the different things relate to each other to figure out what I need to do, whether I need to add, whether I need to subtract, right? Whether I need to use 0.5 or not. Just keeping in mind that everything that you look up on the table just gives you an area between z of 0 and another z. So with that in mind, let's go look up our 0.15 and our 1.15. So 0.15 is right here, so that gives us an area of 0.06. And 1.15, which is somewhere here it is, we're getting 0.375. Let's do that in blue, just to make that consistent. Okay, so putting that in here, all of this, right, this whole blue area is 0.3, oops, that wasn't a 3, 0.375. And this green area is 0.06. So to find what's left, right, to find the yellow, I need to subtract. Okay, so 0.375 minus 0.06 leaves me with 0.315. Okay, so there you have it. And just, I know I mentioned this several times, but just every time you have a problem like this, just draw it out, see where your different z values lie, shade in the area that you want to know, and then shade the areas that you can figure out based on either looking things from your table or the fact that, you know, half of the distribution is 0.5, and then figure out based on that picture if you want to use addition or subtraction or what things you need to add or subtract or whatever in order to get the region that you shaded in.